In the previous session, we talked about our speed, 10 meters per second, that's the length of the room. We walked that in 5 seconds, that was running fast. Now we're going to be using kilometers per hour, and we're also going to be using miles per hour, but not miles per hour very much when we're in physics. But this was 2 meters per second, remember that? 2 meters per second. So meters is m and seconds is s. And we know that 1 kilometer is 1,000 meters. And 1 hour is about 3,600 seconds. Now if I get out my calculator, this is going to be about 7,200 divided by 1,000. That would be about 7.2 kilometers per hour. Now you all have your calculator, so you should check on this. Make sure I don't make any mistake. And the calculator you should buy, that you should have for our class, is a scientific calculator. It should also have sine, cosine, and tangent, as well as regular symbols. So that's what you need. It should be about $12 to $15 for a calculator that's a scientific calculator. Make sure you get that yet. Need that. Now if you want to convert this to miles per hour, 7.2 kilometers per hour. As it turns out, that 1 mile is about 1.609 kilometers. Now most people round that off to about 1.6 kilometers. And when I was about 30 years younger, I used to be a long distance runner. And I used to run these races. There would be 5K races and 10K races and half marathons. I don't do that anymore. But I know that 5K race, to be able to do that, that's about 3.1 miles. That would be a 5K race. Now if you take this number and divide by that number, that looks like it comes out to be about 4.8 miles per hour. But I'm going to get out, I should get out my calculator, but I'm going to let you do that. And you can see if I make a mistake, and if I make a mistake you can chuckle. It's okay. We all laugh at our mistakes, at least I do. And it's okay to make a mistake. In fact, in class I always say the worst thing you can do is not ask a question. The dumbest question that you can ask is not to ask a question and interrupt the teacher. As long as it's a play question and it's related to the material. So that's important to me though. So 7.2 divided by 1.6 should be about 4.8, I think. And that's what it would be. Okay. Now the next thing it says here is so you want to figure out your mass and weight. So we have a bathroom scale, well, doctor's office scale over here. And I personally know that this doctor's office scale lies, because I cannot be as heavy as this thing says. I just don't believe it. And so if you feel like you have to lie about your weight, that's fine. Take it on here, and move this thing over, move this thing over here. And like I said, it's lying. It can't be that heavy. So I'm going to put it back the way I think it should be. I think I'm about 154 pounds. And my assistant is laughing at me right now. Now, I never want to embarrass anybody. Some students are nice and thin. And of course, we always hate those nice and thin people. I was 150 pounds when I got married. I don't know what happened. Well, I know what happened. My wife is a wonderful cook, and she decided to add some pounds to me. So what we do, 154 pounds. That 1 kilogram on Earth is 2.2 pounds. LB is the symbol we usually use for pounds. And I'm going to divide this out, and this comes out to be about 70 kilograms. Now, why is this important to know about your mass in kilograms? Because on Earth, I weigh 154 pounds on a very good day. If I go to the moon, I weigh about 1/6 that much. So I weigh maybe about, 25 pounds. So if I will lose weight, I go to the moon. But actually, in terms of mass is a measure of your inertia. And we won't get to inertia to chapter 4, but it's your resistance to any change in motion is your inertia. So pounds depends on gravity. If you go to the moon, if you're 150 pounds, you weigh about 25 pounds on the moon. If you go to Mars, you weigh maybe about 50 pounds on Mars. You go to Jupiter, it'd be about 7 times or 9 times as much. So it'd be well over 1,000 pounds if you could find a fixed surface on Jupiter. And so that's what we have in terms of weight. So we have no difference between mass. What is mass? It's a measure of your inertia, your tendency to resist any change in your state of motion. Well, weight depends on the gravitational force. Now there's another thing here in section 5. It talks about a block of wood, but I'm not going to bother with that. I think this is all we need to do for this experiment. So we're going to shut off experiment number 1. And by the way, these books are available in the bookstore. And you may have to order them. Go in the bookstore and you can order the books. And my assistant is saying
Online.
online. And my assistant looked them up for me last. By the way, my assistant is my wife of 52 years and 8 months, and she still doesn't know why she puts up with me. I don't know, but I'm glad I have her, that's for sure. And I'm going to say bye-bye now because she's waving to me.